Okay, the second day of notes deals with, it's always law of sines, but it's the ambiguous case. And this occurs when you're given two sides and then an angle, but not the angle in between the two sides. What happens here is, you can either have one triangle, and that happens when the opposite side is greater than the adjacent side, or if the opposite side is less than the adjacent side, you can have 2 or 0 triangles depending on the length of those sides. Either the angle won't, the side will not meet up with the triangle, or you can have either a case where this red line here will form an acute angle or swing inward and form an obtuse angle and just shorten the third side. So that's what we have to test and find out. So here's how you do it. It's pretty simple. It's what we've been doing so far. So you might want to pause here just to get all this information up. And actually, I'm going to do this real quick and make a second copy of this because we need to have 2 of them, because there might be a second triangle, and I'm going to show you how to do that in a second. So make a chart for triangle 1 and triangle 2. So like I said, pause the video if you need to. I'm going to fill in all the sides. Actually, maybe pause it after I fill in all the sides. So F is 34 degrees. This is 3 centimeters, and what do we know? We know that U is 4 centimeters. So clearly the only thing you can, and usually with this case, this is an SSA triangle, there's a clear thing you have to find, and it's an angle, and it's going to be angle U. So we need angle U. So we're going to find sine of 34 over 3 is equal to sine of U over 4. Multiplied by 4, we have sine of U equals 4 sine of 34 all over 3. And then remember, to solve for the angle, you sine inverse. So second sine in your calculator and type that in. When you type that in, you get that U is approximately 48 degrees, 13 minutes. Now, here is where this comes in, this new thing. So this is so that means there is a triangle for sure. If you got an error here, that means you do not have any triangles. So we got the 1. We now have to check. Oh, by the way, we need to put all the information that we had to begin with in triangle 2. I forgot to do that as well. So this was 3 centimeters and this is 4. Okay, so remember how I was saying in the last video that when you use sine inverse in the calculator, you can't get an obtuse angle. But remember, there could have possibly been an obtuse angle of this instead. So to get the other U, it's 180 minus what you just found. And then we can get our other obtuse angle. And our obtuse angle is just the supplement of the original angle. So we get 131 degrees and 47 minutes. Now, if this does not fit, because this and this add up to over 180, you do not have a second triangle. However, this does fit, because if you add 131 degrees and 47 minutes and 34 degrees, you do not go over 180 yet. So now we have 2 triangles to work with, one where U is 48 degrees 13 minutes and one where U is 131 degrees 47 minutes. Now we're going to find the angle ends. So angle N is equal to, for triangle 1, is 180 minus 48 degrees 13 minutes minus 34, which is approximately 97 degrees 47 minutes. Okay, and then the angle N for triangle 2 is 180 minus 131 degrees 47 minutes minus 34 degrees. And if you do that, you approximately get 14 degrees and 13 minutes. So since you do get an angle for that, that means that the triangles work. Okay, now you can do law of sines twice to get that missing piece. So for triangle 1, sine of 34 over 3 equals sine of 97 degrees 47 minutes over x, or we can call it n, I guess, little n. So we get n is approximately, well, it's going to be 3 sine 97 degrees 47 minutes over sine of 34. That's what you're going to type in your calculator, and you get 5.315. To get the other one, we just have to do the same setup, except for the angle changes, because in triangle 2 the angle is 14 degrees 13 minutes. So we get 3 sine of 14 degrees 13 minutes over sine of 34. And that turns out to be 1.318. So there are two triangles, and both of these are possibilities. 1.318. Okay. So those are the answers to that. Now, so maybe write down here the steps for if the triangle is SSA, find the angle, then see if the supplement fits with the given information. Okay, that's kind of what we just did. And it did fit for two of them, and then we're done. If it doesn't fit, there's only one triangle. Okay? All right, so let's do these next couple. So I have triangle sun. Angle S is 13 degrees. Side S is 12. Side U is 60. So triangle 1, I'm not going to make a chart unless I know there's a second triangle for this. Let's see. So triangle 1 is SUN. I have 13 degrees, 12, and 60. So again, I have to find U first. So sine of U over 60 equals sine of 13 over 12. So we get sine of U is equal to 60 sine of 13 over 12. And then we inverse sine that. And I'm going to do this in the calculator real quick to show you what happens. All right. So pause the screen now if you need to finish writing this. Otherwise, I'm going to skip to the next part, which is this right here. So we have sine inverse of 60 sine 13 divided by sine of, no, not sine of, divided by, what is it, 6, it is 12, sorry. And when you do that, notice how you get an error. That's because the opposite side from U, the adjacent side of the angle is too big. So therefore, there is you get an error. So we have no triangle. So there's no answer to this problem. Okay? And then we're done. We can't do anything else with that. So let's do this next one. So set up our triangle, set up our chart. This is P, U, and N. P is 58 degrees. U is nothing, we don't know. What do we have? 9.3 centimeters for that. And then N, little n is 7.5 centimeters. So in this case, we need to find angle N, because that's the thing we're missing. Again, this is an SSA triangle because of how it's set up. So we do need to check both triangles. This, again, you only have to check both triangles though if it is an SSA. If it's not, you don't have to do all this work. You just have to do what you need to do. So sine of n over little n. So we get sine of n is equal to 7.5 sine of 58 all over 9.3. Sine inverse both sides to get rid of the sine on that side. And we get angle N is approximately 43 degrees 9 minutes. Now remember, you have to check the supplement. So check triangle 2. 180 minus 43 degrees 9 minutes. You get angle N can also be 136 degrees 51 minutes. However, does that fit with angle P being 58 degrees? If you have a triangle with N and P of these, there's no way to have a triangle because the third angle will be negative because these add up to more than 180. So this does not fit. So there's no second triangle, no triangle 2. So the final answer, it says find measure of angle N. The answer is 43 degrees 9 minutes. And not 136. Angle N equals 43 degrees 9 minutes. And you don't have to find the rest of the triangle. I'm only asking for N there. So we're done, because this N doesn't fit. So, all right, we got one more. Triangle run. R is 15. R is 9 inches and 14 inches. So I have my chart I'm making. R, U, and N. Angle 15 degrees, side 9 inches. And then we have side N is 14 inches. We need to find this angle. So we do sine of 15 over 9 equals sine of N over 14. Sine of N equals 14 times the sine of 15 all over 9. Again, when you get to this stage, if you're looking for an angle, we sine inverse. Type that in your calculator. Make sure you're in degree mode. You should get angle N is approximately 23 degrees and 44 minutes. However, so that's fine right there. So for triangle 2, angle N equals 180 minus 23 degrees 44 minutes, which is equal to 156 degrees 16 minutes. So now you have to check, does this fit with the 15? And if you add 15 and 156, you get like 171. So in this case, angle N, there are two triangles. Okay. There are two triangles, so the answer to the problem is both these values, because I just want angle N. Now, if you had to do more, I would recommend making a second chart and put that in the second chart for N, and then keep going, just like we did with the first problem. All right, so we have both pieces, and we are done. So that's the only added thing, is you have to look for both triangles by taking the supplement of the angle you initially find. All right, good job.